Okay, right now in question 3, they say that show that ON times GE, right? ON times GE, right, is over ON times G over GN equals to HB times EP, right, times EP over BC. Now, basically, looking at that kind of question, I presume that seeing that there's a GN, there's a GE, there's an ON, we're gonna need to use what we did from our previous question, which is those similar triangles. Remember, from our previous question, we proved that triangle GON is similar to triangle GHE, right? So is similar to triangle GHE. Now we can after doing that, now we can actually use this thing called the proportionality theorem with regards to similar triangles. Now, with regards to similar triangles, I mean to say, now with regards to that theorem, we're gonna say that GO over GH is gonna be equals to ON over HE, then equals to GN over GE, right? Then we're gonna just say similar triangles, right? Just say similar triangles. And then now looking at that given equation there, can you see that we're gonna need a somewhere somehow where there must be a GN, there must be a GE, there must be an ON. So we're not gonna need this side here. So basically in these similar triangles, we're actually gonna need that side here for now, né? And then there's another thing that we may need to do to actually involve a HB and a BC, which I will actually show you along the steps. So for this ratio here, we're gonna need this one. We're not gonna involve that one, né? So now I'm gonna just take that ratio. So far I'm gonna say ON over HE is equals to GN over GE. Now after that, now another thing that I need you to look out for. Can you see that we were given that line GB is actually parallel to line NC? I think, yeah, they say GB is parallel to line NC, I mean to say. So if that line is parallel to each other, we can actually use a proportionality theorem. Now that proportionality theorem, we're gonna say that line HE, so we're gonna say that line HE over EP, right? We're gonna say HE over EP is gonna be equals to HB over BC, right? And then we're gonna say proportionality theorem, right? And then after that, we're gonna state out those lines. So it's GB parallel to NC. All right. So in some way, somehow, we're gonna need to now find a way to actually rearrange that to actually find that equation over there. All right. Let's see. So both sides I have NE. Okay, so I gotta find a way to rearrange those things over there. So to rearrange the blue one so that I can just have HE alone, I'm gonna first, let me do this, right? So it's gonna be HE, so I'm gonna cross multiply there, so it's gonna be first GN, so it's gonna be first GN multiplied by HE, which is gonna be equals to ON multiplied by GE, right? And then to have HE alone, I'm gonna, no, not HE, to have HE alone, I'm gonna divide both sides by GN, right? Which basically I'm gonna have, right, HE being equals to ON multiplied by GE over GN. Okay, now this is looking beautiful so far. Now to make HE alone there, we're also going to cross multiply. So you're going to cross multiply there. And then, so we're going to have HE multiplied by BC, which is going to be EP, right, multiplied by HB, right? And then to have HE alone, I'm going to divide both sides by BC. So I'm going to divide both sides by BC. Then HE is basically going to be equals to HB multiplied by EP divided by BC. Now from there onwards, now I can say actually, therefore, ON multiplied by GE all over GN is actually going to be equals to HB multiplied by EP over BC. And then yes, beautiful. That's how we can actually prove that given equation over there. Alright, so you basically had to use the similar triangles which we proven from our previous question, which is GON being similar to triangle GHE, and then after that we are going to use the proportionality theorem, which states that HE over EP is going to be equals to HB over BC. Proportional theorem, and we're going to state out that the lines that makes a proportionality theorem is going to be GB being parallel to ANC. Alright, and then from there onwards, it was just you rearranging HE from the two proportions that you actually did, and then yeah, you should have an answer which is similar to that one there at the end of the question. Alright.